the real reason we should revive extinct animals. Alright, we got an interesting video today, guys. Let's get right into it.
Look at this. This is rare footage from 1933. You see this dog-looking animal pacing back and forth in a cage? That's a Tasmanian tiger, one of the very last of its kind. It died in 1936, and the species was ultimately declared extinct. But now, scientists are trying to bring them back. And it's not alone. You might have seen headlines about dire wolves or woolly mammoths or dodo birds or passenger pigeons or dinosaurs. De-extinction has become a new and urgent scientific debate that we should all know about. But when I took a deep dive into what's really going on here, I realized that we're getting this conversation very, very wrong. Because we're on the cusp of a huge genetic breakthrough. But the most huge if true thing happening here isn't actually bringing back extinct animals. It's what this means for all the animals alive today. And very few people seem to know about it.
De-extinction.
De-extinction.
Trying to bring back creatures from the past.
We can do this. Resurrect the woolly mammoth.
Dire wolf.
Tasmanian tiger.
It sounds like something out of a science fiction movie.
It's no longer science fiction.
That's the future.
Wow, man. What do y'all think about a fucking woolly mammoth coming back to life, nigga? How they gonna stop that nigga? Hey, bro. Hey, I don't know. What does that mean for the animals today? Like, what does that mean for the survival of the animals today? Do you think? I don't know. It's gonna be crazy, bro. Will it make it harder for us to control them? Like, are we gonna be able to control prehistoric animals? That would be crazy. I'm not gonna lie.
All right, imagine you're a mad scientist and you want to bring back an extinct animal. Here's the recipe. Step 1, choose your animal, like a mammoth. Now, from here, you need to choose one of 3 paths, and for each, you'll need different ingredients. You could try to take a close living relative of the animal that you chose and breed a bunch of them together until you get an animal with traits that roughly match the one that you wanted. This is the same basic process that made my dog Thor out of a wolf. But instead of trying to make something new and adorable, you're trying to make something old. It's called backbreeding, and it can work. Like with this guy, it's called a quagga.
I actually have a little toy quagga right here.
It's a subspecies of zebra, native to South Africa.
They have stripes on the head and neck, and the stripes fade away along the body.
It was hunted to extinction by 1883, but we've already been able to bring a version of it back using backbreeding.
This is a really exciting approach.
And it can work for both animals and plants. But it is incredibly slow. It takes many generations of zebra to get there. And it's a guessing game. You don't know which genes will appear when and which will go away. In reality,
It's a cool method that's been done, but probably pretty limited.
okay, but how about option 2?
Damn, so you just gotta like keep having them like make babies and shit to hope. Wait, you think they can recreate? Wait, okay, so you're saying the zebras are descendants of the ones that we just saw with the fading lines? I'm not a scientist, bro. I'm just trying to get informed here, you know what I'm saying?
Remember in Jurassic Park, they pulled dinosaur DNA from blood inside a fossilized mosquito.
Bingo. Dino DNA.
And then they cloned the animal based on that DNA.
It's all part of the miracle of cloning.
Cool, let's do that. In real life, though, the ingredients that you need for this method aren't just the extinct animal's DNA. You need a whole living cell, because cloning is actually a very specific scientific technique.
Wait, are you dead ass? Well, if we're talking about cloning animals, we got DNA too, nigga. So you saying cloning a human is possible, is what you're trying to tell me right now. With the right scientific with the right scientific equipment, you're saying that you can clone a human person? Bro, I've seen this. So you're telling me these conspiracy theorists that I've been hearing about talking about cloning people and shit, that shit could be true? Nah, bro. We got to do something about this. Nah, bro. It's probably a building full of capsules with human bodies in there waiting to be used. What if they're like soldiers or some shit? They could be using them as soldiers like pawns and shit. Or they could be used to replace somebody, bro. That's the worst thing possible. Like, imagine, bro, a family member goes missing and they reappear. However long it takes to make a clone, they reappear in that amount of time. And it's not even like they're acting different as fuck, but it looks like them. Everything is there physically. But here, they're just not there. That would be crazy, bro. I've seen movies like that, bro. That shit is insane. Hey, we gotta do something. We gotta do something fast.
The long name is somatic cell
I'm not as conspiracy theorist, bro. I'm not no flat earther. I believe in science. You feel me? Scientifically proven shit. You know what I'm saying? But hey, if the science say we can clone shit, my nigga, you know what it means. Nigga, what if AI got a hold of cloning information, bro? What if AI started cloning us, bro? That would be crazy.
nuclear transfer.
It means removing the nucleus out of an egg cell and replacing it with the nucleus of a body or somatic cell of the animal you want to clone. And then you put that egg with its new nucleus into an animal where it can grow. And this actually works. Almost.
People tried this in the early 2000s with an extinct species called the bucardo.
These animals are
in the early 2000s, they was trying to clone shit. Nah, we're in 2025. There's no way. I know they got that shit somewhere. Well, I don't know, but it's not impossible, my nigga.
so cool. But by 2000, there was only one bucardo left. But luckily, this was 4 years after Dolly the sheep was famously successfully cloned. So, in an attempt to save the species, some quick-thinking biologists put tissue samples from the remaining bucardo in storage. And then they were able to take the nucleus from those cells and put them into the cells of domestic goat hybrids.
Wow.
And in 2003, a baby bucardo was born.
Unfortunately, their first clone that was born had a malformed lung and didn't survive. This hasn't been tried again.
So we are able to clone animals when we have living cells, which is wild. But unlike the bucardo, nobody carefully preserved the whole cells of a mammoth. The biggest challenge is needing those living cells in the first place, because it turns out that cells...
Do we even have those cells? Do we have the cells of a woolly mammoth? Do we have the cells of a wait, are sloths prehistoric? You know, like Sid the Sloth from Ice Age? Is he prehistoric? Do we have those still? I don't know. I don't know if he's extinct or not. I don't know.
Cells have a shelf life. Once an animal dies, their cells are typically pretty short-lived, dying off within hours or days. But freezing can dramatically slow this process, which is why there's been hope that animals found preserved in ice, like this 40,000-year-old baby mammoth, might have some usable cells. But so far, no revivable cells have been found. So cloning is hard. But we've got one more option, and this one is by far the most popular.
For the 99.99% of extinct species, we have to use the third method, gene editing.
If you imagine DNA as a group of blocks, each block here could represent a gene. Like this one tells me the shape of the skull, and this one tells me ear size, and maybe this one tells me thick woolly coat. And then stacked together, they give me the instructions for how to build this specific animal. The challenge is, like living cells have a shelf life, so does DNA. Once an animal dies,
The DNA in its cells starts to break down into tinier and tinier and tinier fragments until eventually there's nothing left.
that's why right now we can't bring back animals that went extinct too long ago, like the dinosaurs. Too much time has passed and their DNA is way too fragmented. But if we use an animal that died off fairly recently, or was frozen in just the right way, scientists can figure out what some of those key missing pieces are and replicate this stack of blocks in another animal. This is gene editing.
Do you guys still believe dinosaurs exist? Like the ones from Jurassic Park and shit? No, I'm not. Hey, if a T-Rex was actually alive, you know what I'm saying? I don't see the point. Why the fuck would that shit be created in the first place, my nigga? What is the point of it having these little ass arms being that big, bro? That don't even make sense, bro. That's some weird shit. You know what I'm saying? I just don't see that being real. Like, imagine seeing that shit walk. Nah, that would be crazy, bro.
editing. You compare the stack of DNA blocks of the extinct animal with the blocks of a close living relative to see where the two are different, and edit the DNA in the living relative so it resembles the DNA in the extinct one. This is what they're trying to do with woolly mammoths and dire wolves. But they won't be exactly like the extinct animal. In fact, people online were really quick to point out that these actually aren't really dire wolves at all. It's better to think of them as genetically modified gray wolves. But the thing is, that was intentional. Scientists are choosing which exact traits to manipulate to get the outcomes that they want, and they want to do it by making the least amount of edits possible. I asked the scientist in charge of the Direwolf project why.
I'm thinking about de-extinction, and I'm also thinking about
Bro, they're editing DNA. They call it editing DNA. DNA editing, whatever they. But that's weird, bro. I don't know. It's not natural. I don't know. I like natural shit, bro.
animal welfare. Every time we change the sequence of DNA in a genetic background, there's a risk that something happens that we didn't predict. I want healthy animals in the end. Therefore, my goal is the fewest number of changes necessary to de-extinct those important characteristics.
Okay.
So de-extinction might have a branding problem, because people on one side are looking at the literal definition and saying, that's not de-extinction. And they're right, that's not the exact animal. But then on the other side of this, you have scientists who are saying, bringing back exact replicas isn't really the point. They're not trying to de-extinct the exact animal. They're trying to de-extinct what the animal did. In the end, the whole direwolf or not direwolf debate doesn't really matter. Branding them this way makes for a good headline, but it's not technically accurate. And while the effort to bring back a version of a direwolf or a woolly mammoth is totally cool, I think it's a distraction from what is the real, huge if true, use of this technology. But first, let me show you something. This new phone case is special. It's not just that it's built with insane impact resistance and durability, or that it has a lifetime warranty against yellowing. Those things, if you want to check in the history of Earth, where over 75% of all life was lost, and many scientists say we're going through a sixth right now. And while prior mass extinctions were caused by natural disasters, this one seems to be caused by us. But hang on, even if you don't care about animals and biodiversity, this sucks for us. This has huge impacts on our food and our homes and everything we rely on to survive. And here's the optimistic part. The same tools that we've been talking about to bring back extinct animals can also be used to help animals not go extinct in the first place. This is the part that got me most excited, and this is what I don't see enough people talking about. It's called genetic rescue. Meet the black-footed ferret. This adorable little guy is in need of genetic rescue because
every living black-footed ferret alive today are first cousins.
Yikes. This little guy nearly went extinct in 1979. Because of humans, the population crashed. But fortunately, they've started to come back. The problem now is that this new group of black-footed ferrets
Has really, really low diversity.
So they can save animals. That's good.
Very small gene pool.
Scientists call this the bottleneck effect. If your group doesn't have enough genetic variety, you're vulnerable to things like disease and weird genetic mutations. This is a problem facing dozens of species whose populations put them at risk for genetic bottlenecking. But today, scientists are exploring gene editing to create more genetic diversity in some of those groups.
We can take DNA from a museum stuffed animal from 100 years ago, sequence its DNA, and then edit it into living black-footed ferrets. That's one way to get diversity back, which we are working on.
Another great example of using minimal gene editing to save a species is this little guy, the northern quoll from Australia. Look how cute he is! But they're expected to be extinct in the wild within the next 10 years because of this guy, this toad. This is the cane toad, and it's an invasive species. It's got a deadly toxin on its skin. So what happens is,
So our carnivorous little quoll will eat the cane toad and they die instantly from that toxin.
but scientists found that it's just one single letter of genetic code that makes them either die from eating a cane toad.
Bro, what do frogs do? Like, how do they contribute to society? How do they help improve anything? Like, what do frogs do? What is the point? Are they just parasites? Or what? Like, what is it, bro? Because that thing is ugly, bro. I ain't gonna lie. That's some ugly shit. But I guess if we're looking up, like, if we're looking down at it while it's hopping and shit, But I guess the up close shit, like that's really anything. Like it's the up close picture. Like you ever seen an up close picture of a bug? Like that shit's disgusting. Like an ant. From from my point of view, if I'm looking at an ant outside, it's just an ant. But if we look at like an up close zoomed in picture of an ant, bro, that shit is disgusting. That's probably what it is, bro. That's probably what it is. But ants contribute to society, bro. I don't know how, but they do. They're useful. You know what I'm saying? I don't know how though, but I'm pretty sure they are.
Or completely resistant. Just one letter. So they're working on a way to introduce that one change into the population and make quolls that are able to eat cane toads without dying, saving an entire species. In theory, you could...
I've never seen that in my life, but I look like a skunk mixed with like some type of like, what, chipmunk? I don't know. And a possum? I don't know. Squirrel, a skunk, possum, chipmunk combo or some shit like that. Looks nasty.
Do a lot of this, not just making key animals poison resistant, but also disease resistant or heat resistant. There are projects to do this on coral reefs. Huge if true. But then, why are we trying to de-extinct animals at all? That brings us back to the Tasmanian...
What's up with the T-Rex, bro? You see them little ass arms right here, bro? I just don't get it. And, bro, you only get 2 of these. This is insane. Like, holy nerf. This thing got nerfed. If it had arms to reach, my nigga. Nah, that shit couldn't have been real, bro. This shit don't even look real, bro. Like, do you really think this shit existed, bro? I don't know. I haven't seen any proof. And it's like, bro, I don't know, bro. This shit look
tiger. Humans hunted these tigers until there were none left in the wild, but they didn't understand what would happen next. Without the tiger, Tasmania lost its only apex predator, a keystone species, meaning it has a huge impact on its ecosystem. And without them...
There's been an explosion of wallabies and kangaroos there. They're eating all the shrubs, they're eating all the bushes, you know, that's impacting the bird populations, it's changing the landscape.
Which means that now other species are at risk, like the Tasmanian devil.
They developed this incredibly strange disease, and it's actually like a cancer tumour that grows on their face, and they spread it from animal to animal.
Apex predators used to reduce diseases like this by eating sick members of the population. By killing all the Tasmanian tigers, we created a butterfly effect that's rippling through the food chain to this day. So, some are proposing
the only way we'll ever be able to bring that ecosystem back into balance is to put the Tasmanian tiger back into it.
Tasmania is an island cut off from other natural predators, and many scientists agree that there's no other living species that could replace what the thylacine could do here. But could we actually do this? Well, they're following the recipe. They've identified the animal. They've sequenced the DNA. As for close relatives, this is the closest living animal to the thylacine. Their genetic makeup is 99.9% identical.
And then you just edit that 0.1% where they're different, and that will turn that then into a Tasmanian tiger or a thylacine cell.
Wait, 0.1%? That's actually a lot genetically.
And that's the bit that's going to take a really, really long time to get that bit done.
At this point, though, you might be wondering, whoa, 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 whoa. Did we not learn our lesson from Jurassic Park? What are...
Alright, bro, I'm done. They're talking about T-Rexes and shit, and as you can see, I'm not a T-Rex believer. I'm sorry. Come to me with some proof. Drop a website in the comments if you think that shit is real, or you got any type of proof. Let me know. Drop the link, and I'll go check it out. But hey, without further ado, man, if y'all like this video, let me know in the comments. I love y'all boys. I'm see you on the next video, man, and I'm out.